Hi, I'm Tom and I talk about code. Welcome to another PlayStation 2 programming livestream. Today we're doing more work on my little PlayStation 2 side-scroller. As always, I think the best way to show what we're doing is to just run it. So let's have a look at what's working so far. There is a small graphical error. Hold on, I've got trace logging on. That means we're gonna spend more time printing things than actually doing things. Let me disable trace logging just quickly. Debug. Now let's run, and we will see we have a little side scroller. Now there's this slight problem in the middle, but we're going to ignore that for now. We have a little character that we can move back and forward, we can jump, we can dynamically load in extra levels. So when we get about halfway through this flat point, and you know, I've got this kind of nice tile set I found on itch.io, and then I've got these testing tiles which I'm using, and I use these, the reason I wanted numbered tiles is slightly, it's just a visualization. It just helped me solve one very specific bug. We're going to do away with the ugly tiles, hopefully in this stream. Hopefully once we've dealt with whatever's going on here. So at the end of last stream, it looked like I'd fixed this. And then I tried to run my code on a PlayStation 2, and it looked like this. This is what I got. So that's not good, right? Obviously something was going wrong here. And then with the help of Refraction PCSX2, a really amazing PCSX2 dev who knows everything about the PlayStation 2, he led me to this little problem here where, and this is a very subtle PlayStation 2 issue, I was using the Z buffer mode GS PSMZ 16. Now if I pull up my hardware manual, PSM Z16, yeah, cool. So, combinations of frame buffer and Z buffer formats. Very easy to miss this in the hardware manual, right? Just one little section. The pixel, frame buffer, and Z buffer storage formats have to be compatible. You will notice that so either they both have to be from group 1 or they both have to be from group 2. You'll notice that PSMZ16 is only compatible with PSMCT16. I don't really know. I guess this is just like 16-bit color, right? I think it's RRR. I think it's 5-bit RGB and then 1-bit alpha, I think. Oh, Refraction. Speak of the devil. I summoned him to my chat. Good morning. I'm just going over the things that I did off camera last night, right? So basically, PSMZ16S is compatible with the frame buffer format we're using. So that's good. So I fixed that. I put the S there. And then things started working a little bit more. On hardware, it looked more like this. We could actually see tiles, which is grand. That's really, really good. And I noticed a few other things. I was pre-dividing my frame buffer addresses, and that wasn't correct. There was another thing as well. If we look at how the text0 register is defined, when we pass in a texture pointer, so when we, kind of tell the rasterizer where the texture that we want to draw from lives in VRAM, I noticed I was sending an address, I was dividing it by 64, that was all good, but I noticed it said word address, and I thought about that more, and I realized there was a divide by 4 that I was missing. So now my code, for example, when I set up these addresses, I divide them by 4. Now, this probably isn't the right place to do this, but this is my kludge for now, this is my hack for now, because my library code does not do the right thing, it doesn't pass in the right kind of address. Refraction last night pointed out that maybe it's better to just pass what are these? These are block addresses, I think, right? Because page addresses are the big ones. They're what the frame register uses. And we're going to have a look at the frame register as well, because I just want to double check, because it's still obviously not working properly. FBP, frame buffer base pointer. So it is a word address. It is a word address. So this is literally the problem. And this is why in my code before, I was actually dividing these by 4. Okay, because this goes from a byte address to a word address, but it's still the word address, right? Which is good to know. So now if I run this, maybe this actually just works. Okay, so that's a different bug to last time, right? It's the same issue. The texture that we're drawing when we have it in VRAM is overriding part of our frame buffer, but it's overriding in a different way, so that's good. So we've moved this around, basically. We've moved this around in VRAM. Now, again, last time I drew some pictures, okay? Last time I drew some pictures about what our VRAM allocation looked like. This is essentially our VRAM strategy, right? We have a frame buffer in memory. We have a second frame buffer in memory. We have a Z buffer. This is VRAM, video memory. And then we have a chunk of VRAM designated for the actual game, which is split in half. The first level uses one part, the second level uses the other part. And this starts, it may not start at this address anymore. So let's, first off, have a look at what allocations in VRAM we're logging and make sure that the numbers I've written down still make sense. And they are a little different. 146880. So we're going to annotate this, right? So this now starts at 146880, which is very cool. No, which is quite a different number. Quite a different number. Very, very different number. Okay. 146880. No, my mistake. 114680. This is a very similar number, actually. This is only 300,000 bytes off. Bobbius, good morning, welcome. We're doing the same thing as last stream, but we're going to fix it this time because we've got this happening again. Now, the reason this is flickering, by the way, is I upload the texture into VRAM at the start of every frame. If I stop doing that, it'll stop flickering, if I only upload it once. But I don't think there's any real reason to not upload it every frame. The PlayStation 2 is kind of good at uploading textures into VRAM, so I'm going to do that until it's a problem, and it'll never be a problem. Unless I have a weird synchronization issue. But as far as I understand it, this is really common. And I hope this shows up. I can't see it on my stream preview because it's flickering too fast. But like this, right? It's flickering because it only overwrites one of the two frame buffers. And that makes sense. If this was on both of our frames, then something would be weird because we're only uploading this texture into one place in VRAM. And that place just happens to override this frame buffer, but not this frame buffer. Now, which frame buffer's which? I don't know. We could do trace logging and try and pause when it's drawn and have a look. That could help. Bobbius says it comes and goes since we're recording at 30 FPS. Exactly. We're rendering at 60 FPS, I guess. So there's like synchronization stuff. Cool. So we can see where VRAM allocations happen. 12924 12902 114. What happened to 1146880? Where did this go? Because this is where. Oh no, sorry, that's the Z buffer. So we're at 290240. Reading comprehension is hard sometimes. Let's actually just get the eraser out. Let's get the eraser. Let's make it big. That's not what I want. I want this one. Okay. I just drew stuff. Where did I draw that? I drew that on the background directly. That's fun. Okay, there we go. No, hold on. Wait. I wanna. There we go. There we go. Okay, I'm gonna stop drawing directly on the background. That's gonna make things better. So what did I say my address was? After we've done all of the VRAM allocations for frame buffers and Z buffers, 1290240. 1290240. Okay. Refraction's gone to relocate his bed. That's not a sentence I expected, but it is a sentence we have. Good luck. Good luck. Okay. So, 1290240. So the entry level, the first level we try and allocate 1290240. That should be fine. 1290240. Allocate it for this. We align by 256 bytes. That's more than necessary, I think. I think it should only need to be 64 byte aligned, block aligned, but I'm doing 256. I figure it's better to be a bit conservative, unless that's somehow causing an issue. Tileset VRAM address. Okay, so this looks fine. This looks fine. This looks good. These are all very sensible. And then when we log it, so down here we allocate a much higher band because again this is split in half. So what we're saying is 274, 2742, 2722, 742, 272, right? So these blocks subdivide the rest of VRAM up until approximately, the limit is 3FFF left shift by 8, I think. This is the largest block that we can represent. Yeah, this is the largest byte address that we can represent, because we can represent this many blocks, and blocks are 64 bytes long, but word address blocks, we can have this many word address blocks, so we add an extra 2 to a number of bytes. This is the total number of bytes. Maybe we should just work in number of blocks. Anyway, or words. I don't know. I think what we're doing is okay. So basically, as we're working through this, right, we would expect when we're drawing our first texture. Oh wait, hold on. Yeah, so if we look at the texture base pointer that we're using, that should tell us where this gets uploaded into VRAM and where we're drawing it from. Because we know it's referencing the right place in VRAM. We know that because despite the strange frame buffer interference, the correct tile set is actually being drawn. So if it wasn't referencing the correct place in VRAM, we wouldn't see the correct tiles being drawn, right? We would see random garbage here instead. So that's good. That's good to know. That's good. So if we look at what this register that I was talking about before, the TextO register, if we look at what's in the TBP section of this register, right? And if that does not overlap with a frame buffer, we should be fine. We should be okay. That should be all we need to test. I suspect this won't work. So Refraction showed me a cool trick last night that I'd literally never seen before. And I suspect this is actually running now, so let me just... Yeah, oh boy, I am dumping stuff in here. I have got a really big directory full of debug information. So if you go into your emulator, right, PCSX2, you go into settings, you go into debug. There's a setting called dump.gs draws, and I've got save frame on as well. I don't know what save frame does. I assume that actually saves a picture of the frame that's being drawn. I'm not totally sure. But we're going to dump the first 100 draws we do when we run the emulator. So I can do this. And we've just dumped 100 draws into a file. So let's go have a look at that file. Cool, so we've got a bunch of stuff. We've got a big old directory with quite a few files. 200 files in it, okay? Some of these are PNGs. So if we look at the PNGs we've dumped, which emulator is this? This is PCSX2. It's just PCSX2. It's the emulator. If you're using something else, you're probably doing it wrong. It has good debug features. So for everything we draw, we appear to get this little file printed out, right? So this is... Yeah, okay, so this is, I don't know, draw 4? I'm not 100% sure what all these files mean, but I'm going to interpret them as best I can. So this is what actually has been drawn, and this is the alpha. And then here, I guess this is the rest of the tiles, and this is the alpha. And then I assume this is the camera moving, but I'm not totally sure. And so we draw this, and we get pretty much the same thing. I think our little box is going to slowly move as we go through, and I'm sorry for the strobing. But you can see what we observe in the actual rendering, right? One frame where there's no texture. One frame where this texture is drawn over our frame buffer. So, and it looks like this is on... So on even frames, we have this, and on odd frames, we don't. So we can look at corresponding files that have the whole context of the graphic synthesizer for when each of these frames are drawn. So let's look at the context at 88 and at 92. Okay, so let's vi context 92 context and context 88 context. Okay, so what we should see here in the context, and this looks correct, this looks very correct, is one of these frames, our frame register says the frame base pointer is 0. the other context says our frame base pointer is 8CO. And that's good, because we have 2 frame buffers. We expect them to swap as we render different things. Now, let's have a look at the text O register in each of these contexts. And they're the same, so that's good. That's good news. So to have a texture rendering over the thing, and was it it was 88, or was it 92 where it was rendered over? Hold on. Let's go back. So let's go to 92. 92. 88 nothing, 92 something. So 88. Yeah, and this is the one with the higher frame buffer. So this is all consistent and makes sense. So let's see if we can... Now I have a bit of VRAM stuff here as well. Okay, so this is no longer the numbers we're actually working with. That's okay. So we'll say context 88, CTX 88. Okay. The frame buffer P, the frame buffer page is the frame buffer page times 32. I don't know what the significance of this is. So it's hex 8CO. Okay. So 8CO. And what did I say it was down here? I said I didn't say what our frame buffer addresses were. We should probably make note of this as well, and we can actually do that if we scroll up. The first frame buffer is of course at 0. The second frame buffer is going to be, so this is 0. The second frame buffer is at 573440. 573440. Okay. So hopefully we can map between these numbers. 573440. Actually, hopefully we can't map between these numbers, because hopefully this mapping is where something's gone wrong. Maybe. And because, well, okay, so the other thing is, right, what's text O? Text O is 13BO, and this is actually easier to verify. So text O 13BO. So we should just be able to left shift that by 8, and we'll get back this number. No, this number. One of those two numbers. 13BO. So Python 13BO left shift by 8. 1290240, 1290240. Okay, so text O is being set correctly. This is good news. This is really good news. And this frame base pointer, so this should be left shift. If we left shift this by 11, we should get the word address of the frame pointer. So if we left shift this by 13, we should get this number. And let's actually do it in reverse. So let's do 573440. Let's right shift it by 13, and let's take the hex of this. What do we expect this to be? That is a smaller number. That is a much smaller number. And that could explain why frame buffer has a texture drawn over it, right? So let's do the opposite now. So 8CO, left shift by 13. This is a much bigger number. Indeed, this number is actually quite close, really, to 1290240. Actually, no, it isn't. This is way out in space. Whoa, hold on. This is 18 million. So, okay, so now we have to go back and we have to look at the frame register again. Page 111, I should remember this. 110 actually. Have to be 9 bits. So we have 9 bits, okay? 9 bits to represent this number. Now, 8CO. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, frame base pointer times 32. Do we have to divide by 32 as well? So 8CO divided by 32. Okay, so this is actually the same number. I don't know why this is multiplied by 32 here. There's probably some weird technical reason. But, in fact, we get the same number. The calculation appears to be correct. So that's good. I should have waited till refraction was here to go through all of this, but this looks correct. So we can check this. This is fine. And the TBP is what we expect it to be as well. So why is the texture being drawn over the frame buffer? Oops, the values are the same as with Texo. Ah, okay, so you can just eyeball any overlap. That's cool. So just eyeballing, right? It doesn't look like there's any overlap here. Actually, how big is this? This is... That's somewhere as well. Hold on. That's 57... Oh yeah, it's 573440. That's how much we're allocating. So this should go from... Well, this to double this, right? So... Oh my gosh, what am I doing? 8CO times 2 as hex. 1180. And there's no overlap. None. No overlap. But yeah, this stuff is really cool. So the frame base pointer is set to something we expect it to be. It's being set correctly from where I think it is, which is good. And Texo points to the correct spot here as well. And it does not appear that there is any overlap between them. So I'm more confused. I'm more confused now about how this can happen. Because what am I? I've got so many things open. Okay. No, that's not what I want. Okay. So where is my Z buffer? My Z buffer is just immediately after that. My Z buffer is little. So it's, well, my Z buffer starts at, so 1146880. Let me write this down as well. Actually, let me double check it's set correctly. Let me get it from the horse's mouth. Z buff 1180. So that's 2 times this. So that's what you want, right? Because the first frame buffer is at 0. The next one is at the size of the frame buffer, and then the Z buffer starts at the next multiple of the frame buffer size. And it is only 100,000 bytes. 143360. 143360. So it's, so if I 1180 I can get this into the same space. Hold on. So divide by 32. Hold on. I've got to do brain here. 11. So I've got to engage my brain. 143360. 143360. And this is 143360. So this is left shift right shift 13 multiplied by 32, which is divide by 2 to the 13 times 2 to the 5, which is right shift 8. So if I right shift 8, 143360. Okay, I think that makes sense, right? So 143360 560. So let's do hex 1180 plus 560 and get the result as a hex number 13BO. So it should go until the start of this texture. So this is where the Z buffer should end. So maybe I need to leave some padding, right? But that doesn't seem like the thing I should need to do. It should be okay. Yeah, these numbers all work out, and they come directly from the actual GS context, which is really strange. Okay, so let me go back into my test level that's causing the problem, and I'm going to redo this thing. Int. And I'm going to do this thing where I only upload the texture of the first frame. My uploads are not overriding. So this is the other thing, is checking the... Well, so if my uploads are overriding, right? Like, what would that mean? Because when I draw them, TX0 is set correctly, right? So I guess it's possible that... Let me check. It's all the same memory. It is, but if I was overriding it, like if I was writing it to the wrong place, then surely my draws would fail. I guess it's possible that I'm just writing too many bytes. And I could upload over the frame buffer breaker. Okay, so TRX dear, no, my favorite register actually, BLT buff. This is the one I care about. Okay, so word address divided by 64, width in pixels divided by 64, destination base pointer, word address divided by 64 between buffers. Is this the one? Is this the one I want? Draws never fail. Yeah, it'll always do something. It'll always do something. So let's go into my library code, draw 2D, upload texture. Okay. So this should be okay because the VRAM address we're passing through is a word address. So that feels okay. Maybe I can grab something from the context. Now I just ran this again, so I should have probably, I think I've doubled up. Maybe, or maybe they just override. I guess if it's all the same file names, they'll just override them, right? So OOO BLT bit built buff. Will any of these contexts actually capture this transfer, these registers? Because by 0004 oh no, that's 4T, by 04 we actually draw, do we? Maybe? Yeah, by 4 we've drawn something. Now, I don't fully understand what's going on here, right? This looks like you can literally see, like, here's... I don't know. Interlacing, man. They should show the last transfer. Yeah, okay. So anything after... Well, this is weird then, right? Because you would expect by 0004 context that... Oh no, so we have SBW. That's the right... I've got so many things open right now. See, SVW and the source destination. Wait, I can't remember how these registers work, but I guess the destination is the important one, right? Where I guess we don't have a source because so the transfer, never got around to it. The actual transfers in the vertex file. That would be interesting. So we're sending a 64 width texture. Storage format is 0, and the base pointer we say 29D8. Hold on, is that a different 29D8? Have we seen 29D8 yet? Have we seen 29D8? 29D8 I would assume would be this. Right shift by 8, so 2742. Oh, I guess I'll left shift this. I guess I'll do this left shift. So Python, I already forgot what that number was. 29D8 Python D8. We're gonna left shift it by 8. 27422727. 472272. That's this one. So this isn't the transfer that, yeah, uploads is only a destination. This makes sense. I forgot what I was doing. We're not copying around VRAM. So this is this texture, which actually isn't the one that's causing issues. This isn't the one that's overriding the frame buffer. It's the other texture. It's the texture here that's giving us drama. So we want to find the other, and this is actually the right scene. So context ESP context. I can't see where we ever upload it. I can't see when this ever 004. I can't see what the base pointer is actually. Because we're never doing an upload with the DBP set to 0, right? That wouldn't make sense, because that would override the start of the frame buffer, not the middle. Yet. And yet. And yet. But we can see in the logs, the thing, and we can see in the logs, the like, it's not this one, it's not the upper one. Shows the last one, uploads, debug, and use renderdoc. Or I enable my trace logging and I print the shit out of everything, which I have actually done. Let me do it again. Actually, no, well, I should just be able to pull up run. Oh, the numbers will be a little bit different. Okay, so here's what I'm gonna do. I'm gonna go into main. I'm gonna re-enable trace level debugging. I'm gonna make and this is gonna spam the shit out of everything. This is like the whole draw buffer that gets sent to the graphic synthesizer. This is my entire draw command. Okay, this is the whole screen, which is kind of cool. Okay, so run.log. Annoyingly, I have these color. Let me less run.log. Thanks Stranger for pointing that one out. Also thanks Stranger for donating me money to buy a freaking capture card. That was unexpected. Okay, so uploading text. Okay, so this is our EE pointer, and this is the word address. So we right shift this, so 322560. Yeah, okay, so let's try this. Let's try this number. 322560, right shift by 6. 13BO. And that is what we saw in text O up here, 13BO. So that looks correct. Okay, what about the other text? Well, and this is the other one. This is the different texture that isn't being drawn. 322560. 322560. Wait. 322560. This one. Why did that happen 3 times? That doesn't feel right. Okay, maybe we've got a lead to pull there. We probably don't want to call upload. Something strange. 685568 hex 685568 left shift, right shift by 6 29D8, which is the magic number we had before. So let me just also double check. So VRAM address, we divide this by 64 because that's what bitbuiltbuff says we should do. TRX pos TRX reg. TRX reg. Let me double check the format for this as well. TRX reg. Width of transmission area, height of transmission area. Units of pixels. Pixel mode must be the one set by bitbuiltbuff. That is okay. That's okay. Drinking from the fire hose. This is very accurate. This is very on the nose. I like it. I like it. Uploading text. So, frame end. So our first frame ends at. I don't have line numbers. That's cool. One problem I might have. I'm so ready for this. The wisdom of refraction. It's gonna save me. BO might cause me problems if it's not page aligned. Do transfers have to be page aligned, even if they're not? I mean, I can make everything page aligned. I can do that. It feels very wasteful if my textures are 64 by 128. So is the idea that I actually need to upload more stuff at once, right? Like, drawing a texture that's only block aligned is fine, but if I want to... Okay, oh, yeah, I see what you're getting at. I see what you're getting at. Now, annoyingly, I have to do this several times. Test add. It's pages are 2048, right? 2 to the 11. Is that page? Not this. Especially swizzling Z page. Yeah, this is true. This is really wacky. I don't understand why it was done like this. I imagine it's like memory access patterns, right? It's something to do with the way it's read and what can be done in parallel, I guess. You think they were high? Yeah. Imagine the year was like 1990X, and you got the original hardware manual, poorly. You're an you're Naughty Dog, and you get the first edition poorly translated Sony hardware manual, and you're just like, what? What do I do with this? Like, they take. Oh no, I've got trace locking on still. That was weird. Let's disable trace logging. But yeah, like it would be really been a magical time to just be like, you would feel like a wizard the first time you got anything running, right? Okay, so this is because I know why this is. That's because we did this. So let's actually revert this and upload it every frame. If we don't upload it every frame and it's part of the frame buffer, then after we've drawn once, it's going to get wiped out. So page, and just for posterity, let's do a clean run, a clean build and run. Okay, so in case you can't see on stream, we've still got the issue. Some people took advantage of it. Double half clear. They clear pages of memory half with frame and half with Z. That's insane. That's really, really cool. And again, right, I guess you can do both. Like, it's to do with parallelism in a sense, right? Because you can do two different things at once because they're not, like, I don't know. I'm sure there's a very real technical reason for why it's like that. You can kind of taste it if you think about it, right? But I have no idea how it would work. And I don't know how hardware memory access works enough. Am I using SDL? No. I'm writing my own graphics driver for the PlayStation 2. I'm putting my own bits in buffers. I'm writing my own GS commands myself. You can clear pixels 1 to 32. The Z, yeah, so as you're clearing pixels, phone typing, always the worst. As you're clearing pixels, so what refraction's describing, in case it's not obvious, is, like, in this kind of setup, right? Instead of having the Z buffer down here, we would actually tell the PlayStation 2 that the Z buffer was at the same address as the frame buffer, and then we would set up a drawer such that the Z buffer was zeroing things out, and you only need to draw half as many pixels because, this part of the frame buffer and this part of the Z buffer don't overlap, essentially, or they're kind of swapped. So if you draw this part, the Z buffer clears the other part. It's a really, really fun trick. I don't know how practical it is. I don't know how much time you save. Like, were people really so starved that they needed the absolute fastest screen clear possible? I thought the PlayStation 2 was a fill rate machine, but every little hack, it's a fun hack at least, You don't want to spend a bunch of your frame doing the boring bit. Anyway. I'm a bit lost, because that's, like, okay. So the other thing I could do is just keep upping this number and keep trying to, allocate at a higher and higher alignment. But I don't see how that's ever going to really help. We still end up with it in the same place. Strips of single pages, didn't need to flush the page caches off. And yeah, this is what PS2 SDK does, right? It does the little narrow strips. And again, if you're interested in this stuff and you happen to have a copy of the system hardware manuals, if you look at the back of the book, it goes into how data is structured in a page. And so you can actually see this, right? So we have a 32-bit frame buffer. We actually have a 16-bit Z buffer, so it's not quite the same here. But you can see the way the blocks are arranged, 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 6, 7. It's this really wacky layout, which is literally reversed in the Z. The Z literally does the opposite thing. When you have not CT16, that's not very interesting to me. Where's the Z16S? Is that here? Anyway, yeah, this stuff's really wacky. Wacky. Points to a block boundary. A buffer starting address points to a block boundary, not a page boundary. So this is what I'm doing, right? I'm setting TBP 0, text 0, TBPN, transferring between data buffers, block within a page. Blocks are arranged as followed. So this doesn't really matter to me. I hope not. Pointing to block 9. I don't know. It's kind of wacky, right? It's kind of a wacky layout. And then you've got the stuff for the actual pixel format, which is fun too. And then that's the end. That's literally the last thing in here. You just get all these cool diagrams, and it's very, very cool to see. I have not fully internalized the practical applications of this layout and how to abuse it, other than the half clear thing. That's a fun trick. So I don't really know what else to try. That's kind of the annoying thing, right? This just overlaps, and I don't understand how. So maybe I need to do these number calculations again, annoyingly, but now the numbers should be different. So if I look at, what was it? 88 and 92. We should see, so texo, tex 13bo. I guess that's already page aligned because it came from, and this 13bo. Oh yeah, we're drawing the same texture, that's okay. And then the frame should be different, 8co. And so the frame buffers are in the same place. The frame buffers have not changed. That's good news. We know the upload is going to the right place. Lower 5 bits should be 0 for page alignment. 13bo. Lower 5 bits. 13bo. Hold on. 13bo. B. That's okay. Lower 5 bits. So that B. Oh wait, B's odd. Yeah. So this is 0001 0011 10110000. So this is actually not page aligned. 13C0. Yeah. You move the O. It becomes 1100. That would be okay. How does this happen though, right? Because we should be 13bo. We said 13bo was this. So, but we should be aligning this. Okay, don't judge me. Hold on, this is the wrong file. What am I doing? We should be aligning with this really stupid loop. Okay, so we're kind of saying while we're not aligned, increment the thing. So how does that happen? Because yeah, you're absolutely right. Hex 13bo. So we need to. So what am I doing? 13bo. And we've already divided this by 4, so we need to multiply it by. No, hold on. We need to left shift it by 8 to get back. So this is what we 1290240. 29024. Yeah, so that's this. 1290240 mod 2048. So this is, what's this in hex? Hold on, let me visualize it. Well, that's easy actually, it's just shifted. So the bottom, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, only the bottom 12 bits of this. And this address, 4EC00000. So that's fine, isn't it? I don't know. I don't. So do I need to be more aligned? Do I need to go higher? Oh, is this 2048 times 4 essentially? Which is not. Multiply the result. Yeah, okay, hold on. So wrong file again. So basically 2 to the 15, right? So 2048 times 4. Let's just go for a big number. This is too big of a number, but it's something to try. If this works, I'm going to be upset. And it didn't work. So let's check. Let's check in with this. Let's just... text O, sorry. 13CO. Exactly like you said. But it's still not working. So that's kind of good, in a sense, right? I'm glad that it's not this weird upload thing. But... it's a possible bug that's maybe better. This is kind of how I feel right now, you know? I guess it's good that I can chuck textures at random blocks and that works. Well, at least it breaks in a consistent way. Do you know what I'm going to do? And unfortunately, I can't show it. But I'm going to turn my PlayStation 2 on, and I'm just going to run it on my PlayStation 2, just to be sure. So, I don't know, feel free to ask me some questions, or just like, you know, generally chat for a bit, while I just make sure that this replicates in the same way on actual hardware. Because if it doesn't, that's also kind of good news, right? I can just report a bug, it's someone else's problem. Not the problem, could be a problem, yes. This is a good way of saying it. Okay, PlayStation 2, side-scroller test. I've got to run PS2 Link, which is always a cool program. Am I using the software renderer? Yes, this is all software rendered. I only run PCSX2 with the software renderer. That's not completely true. Actually, wait, hold on. Wait, let me double check that. I was running a game. Oh, I hope that's not the case. I really hope that's not the case. That would feel really silly. Okay, so that got worse. So that explains why the results were so different between hardware and emulator. I was using the wrong renderer. So that's good news. I can fix all my problems by just not rendering anything. I kind of like that option. Nice. Okay, I'm going to run to the bathroom really quickly. I'll be back shortly. Alright, so... Where were we at again? I can't remember. Oh yeah. That's right. Yes. Very good. Oh yeah, I should have actually known, right? Like it wasn't logging, it wasn't printing the right stuff for the software renderer. It actually prints different stuff. You can tell. You can actually see the difference. Cool. So, welcome back. I don't know if I feel very welcomed back by this. God, TBH. It's okay. Suspicious, only the bottom half freaks out. Well, the top half flickers as well. So here's frame 1. Actually, let's do this the proper way. Let's be thorough, okay? So let's start.png. So here's the first frame we draw, okay? And that's the alpha. The alpha is less white than it was before, which is interesting. So here's the first real frame we draw, I guess. At some point the camera's gonna... Yeah, so the camera's caught up. So we draw this. And then we draw... What's this in between frame? What the hell? I'm very confused by these draws. Okay. And then there's this. Alpha gets doubled in hardware if it's 120 or less. That makes sense. Yes. I love the PlayStation 2's alpha. I love the weird color range. It's such a cool, fun thing that the PlayStation 2 does. Okay, so we have this frame and we have this frame. What the fuck? Right? What is happening here? How does this happen? Because then, okay, so there's actually 3 frames of note. They're all very different. This is so strange. It's like I have 3 frame buffers. How do these 3 things all get drawn one after the other, right? Also, these are all in context 11. What? I don't know what these numbers mean, unfortunately. 12. Okay, so PC RTC. See, that's also interesting. So VSync. I have not looked at any of these files. So VSync. I guess should I look at one related to one of those frames? Let me pick a choice frame. Let's pick one of the funky ones. Let's look at this one. So 07. Okay, so if I VSync 007. 007. ITEX. Oops. RTO. Wait, what? Wait, hold on. Am I looking at the wrong one? 00007. 113116. Display, yeah, okay, disp FB. Okay. So the base point is 0. So I'm happy with that frame buffer, right? And that is the same in all 3. I don't know if one of these is better to look at than the other, but let's stick with this one for now. So display. This seems sensible. 3, I can't remember how this is done, right? It multiplies something. Display. Mag H, magnification, the H direction. There's a table that tells you what these are supposed to be, but I think 3 made sense for 440. In horizontal direction, sorry, hold on. This mag H. Yeah, there were things that told you what to look for. Mag V, I'm going to assume that's okay. 3 is normal, 0 for vertical. Yeah, that's good, that's good. P mode. PCRTC. Okay. Read circuit 2. On. CRT output switching, always 1. That's good. The one that should be always 1 is always 1. Alpha value selected for alpha blending. 0. Read circuit. Well, that's fine. So we're just not doing blending, which is good. Method. SLBG. Sure, whatever. Fixed alpha value 128. That's right in the middle. It is not always a 1. I like this. This is good. This is good. I guess. Yeah. That's a dead end. Oh my gosh. This is really getting into the nerdy signal generation stuff I don't understand. FFMD. So S mode 2, FFMD. Setting for interlace mode. Field. 0 is every other line. Okay. Isn't that what I want if I'm in an interlaced mode? Oh, frame mode. You're right. You're right. That makes a lot of sense. This is the wrong thing. Wow. So mode frame. Okay, so that's different. Should I just not use an interlaced mode? Is that also an option? Like, what if I just go... What if I just go... We go the full 640 by 480 non-interlaced, right? What does this look like? Okay, so this is mag H, right? Or mag H not being set correctly, mag V not being set correctly. 224. 224. What will be 224 for height? If we're non-interlaced, if we go to non-interlaced, it'll still need to be a 224 high buffer. Is that right? Non-interlaced mode is only 224 high. What the hell? So if you set the height higher... Oh, well, let me just change the thing. Let me just change the thing. If you set the height higher, it just halves the horizontal. Okay, so only DTV properly. Cool, that's good to know. That still doesn't look right. I still feel like I've missed something here, but this is still more zoomed in than I was before. Okay, so this, we've still got some overlap, right? But this is maybe better. But then what do we set? It looks less broken. Still some breakage. But it's the wrong scale, right? So, oh my gosh, what did I do here? How did I, what? When did that, how do I keep halving? I feel like I'm halving my screen height somewhere that I shouldn't be. I feel like I'm dividing by 2 somewhere. Screen height, screen height, screen height, screen height, screen height. So that is okay. If I interlate. Oh, yes. Okay. Times 2. Okay. This is a kludge, but it's okay. This is confusing. I don't know. I struggle with this. And I need to do it here as well, I guess. That's okay. This is not what I expected. This is not where I expected this to go. Does only that one need to be? I swear this worked, like, just before. So that didn't have the weird interlacing. Let's go to non-interlaced, hold on. But then this is 448, so then this is half height. I don't know, man. This stuff's whack. But do I need to set the actual screen dimensions correctly? Okay. This is still more zoomed in than I think we were before, right? But at least the aspect ratio looks mostly correct. We're a little bit skinnier. And we're still overriding some weird part of the frame buffer. which I don't love. I would like to not do that. I'd very much like to not do that. Weird. What is going on? So I guess I should look back at the vsync files, right? These are going to tell me a lot. And it's good to kind of know that I can look back at these. Display, P mode, FFMD, FFMD 0. This is field mode. Read every other line. Read every other line. Read every line. Okay, so FFMD still isn't being set properly. That's going to explain something. That's going to explain something. Look at my width. Look at my pointers. FFMD. FFMD. Okay, so FFMD. Let's see if we can work out why I haven't set this properly. So gs.c, set fields, format. No, hold on. GS. What am I calling? Set output. FFMD. FFMD. We're passing that into GS set mode, which is PS2 SDK. Graph set mode. FFMD. This should be okay. If we could disable. There's no weird special logic here. I set them to the same file. Oh, the file names might be different. I set them to the same folder. Maybe I'll just like clear this directory and rerun before I get lost in PS2 SDK library code. Yeah, okay, they're different. They're very different, actually. We don't have... They're all 0. FFMD is 1. Yeah, cool, cool. Beautiful. I should set up a script to do that. Just clear everything in that folder. Wow. Okay, so my goal for today was to sit down and hack out a little VRAM bug and fix this, and it's turned into something else. I think I'm unfortunately going to have to head off. I'm just getting some messages. Thank you so much, Refraction, for the help. I feel like I'm on the right track, and I feel like I just need to spend some time looking at these files and trying to work out what's going on. I can do that and refer to the hardware manuals and see if this makes sense, but I think this is going to go better if I'm not streaming it. So thank you, everyone who has been watching. Let's have a look at this question while I find someone to raid who knows from that era. If you're asking what kind of graphics theme, no, not demake. What are they called? They're called PS2 era graphics. I don't think there's really a name for it, right? Like the PSX era has a real aesthetic and like the limitations are really obvious. You get things like vertex wobble. There's a real vibe you can lean into. The Nintendo 64 has a really distinct texture style. The PlayStation 2 is such a flexible and powerful piece of hardware for its time, especially that there's not really one PlayStation 2 aesthetic. Lots of different games do different things. There are certain things, like certain kinds of post-processing, that kind of like polygon blur. I don't know how to completely describe it, but that kind of like filtered look that lots of PS2 games do, but it does not have a specific name. And once you understand how the hardware works and how flexible the hardware is, I think it's kind of obvious why. But yeah, thank you so much, Refraction. Have a good sleep. I really do appreciate you coming and hanging out and sharing your vast PlayStation 2 wisdom. Cool. Okay. Compiler dev written in C, game dev. Let's throw some raids over to a compiler dev, because that's my kind of stuff. And thank you so much, everyone, for hanging out, for tuning in. This has been great, and I will catch you all next time. Hopefully with some good results and some more exciting game development. But I love getting in and working out these PlayStation 2 problems. It feels very fun. It feels very rewarding. All right. Thank you so much. I'll catch you next time. Bye.